For part C of problem number 4, we're finding the intervals of concavity and the inflection points. So as we know, that is going to require us to use our second derivative. So beginning with our first derivative, which was f prime of x is equal to negative 2 sine x times 1 minus cosine x, I now need to take the derivative of that to get my second derivative. So this is going to be product rule because I have a product here. So this is my first and this is my second. So my f prime prime of x is going to be first, so negative 2 sine x, d second, so the derivative of 1 is 0. The derivative of negative cos x is going to be negative sine x, which makes a positive sine x. And then second, so there's my 1 minus cosine x, d first. The derivative of sine is cosine. I still have the negative 2 with it though, so that's going to be negative 2 cosine x. So then this will need to get distributed. So I have f prime prime of x is equal to negative 2 sine squared x. And then negative 2 cos x times 1 is going to be negative 2 cos x. And negative 2 cos x times negative cos x is going to be positive 2 cos squared x. Okay, so now I am going to do a little bit of fancy footwork here. And again, I want to remind you, this is a problem on a review. This is not the test problem. I'm not going to put something this challenging on the test, okay? But first of all, if you factor a 2 out of all of these terms as a GCF, then I'm going to do a little bit of rearranging here. If I factor out the 2, I'm going to put the cosine squared first. Okay, so that was from my third term right here. And then I would have minus, because I factored out a positive 2, so that I would still have the minus sine squared x. And then I still have that third term, which is negative 2, or sorry, I factored out the 2, which is just going to be negative cosine x. And so here's the fancy footwork. This term right here, these two terms, cosine squared x minus sine squared x, no, they are not a Pythagorean identity because it's minus, not plus. However, this is one of our pre-calculus double angle formulas. And again, didn't expect you to remember that off the top of your head. This is a challenging problem. So cosine squared x minus sine squared x is actually equal to cosine 2x. So I have 2 times cos 2x, and then I still have the minus cos x, right? And of course, when I'm finding my critical values of my second derivative here, I need to set this equal to 0. So just to simplify my life, I'm going to divide by 2, so I don't have to worry about that. So I get 0 equals cosine 2x minus cosine x. Okay, now where does this equal 0? I don't know. But here's something that I could do. Again, just kind of thinking outside the box. If I add cosine x to both sides of the equation, then I end up with cosine x equals cosine 2x. Now, wouldn't it be nice to know where those two functions are equal to each other? Well, one thing that I could do using my resources is I could graph them both on my graphing calculator, and I could calculate the intersections of these two curves. So let's put a little note here. Graph both on calculator. Find the intersections, because the intersections of these two functions are going to be where the two functions equal each other. So I'm going to go ahead and I am going to grab my graphing calculator. Here it is. And in my y equals, you can see I have cosine x. And in my y2 equals, I have cosine 2x. And since my interval that I'm looking at for this problem is from negative pi to positive 2 pi, when I go in my window, here is negative pi, that negative 3.14. Here's positive 2 pi, the 6.28. And my x scale right here, I'm actually going to change to pi over 3, just because I'm privy to some information on this problem that you are not, but it's going to help us immensely when we're looking at our intersections, okay? So if you didn't know that, that's totally okay. Wouldn't be expected. The calculator will do the calculations for you, but it'll just be easier to see. So I'm changing my x scale to units of pi over 3. And then since I know from part A that my, or actually part B, that my maximum and minimum right now are just at -2 and 2, going from -5 to 5 is going to give me plenty of leeway on my y-axis. So I'm going to go ahead and I'm going to graph this. And there are my two functions. And of course, I'm interested in where they cross each other, right? Where they touch each other, because that's where they are equal to each other. And so again, I can use the calculator to figure it out, but notice right here, you can see because I changed my x intervals to counting by pi over 3, you can see that I have an intersection right here at -2 pi over 3. I have an intersection right here at 0. I have an intersection right here at +2 pi over 3. This is 3 pi over 3. I have an intersection right here at 4 pi over 3. This is 5 pi over 3, and then my last intersection is at 2 pi, which is 6 pi over 3. So again, you could use the second level, calculate, and number 5 is the intersect, right? And do first curve, second curve, make a guess. You could do all that, but I can see it because I put in my units at pi over 3, and this is going to save us a lot of calculator time here with calculating our intersection points. So just trust me when I say that my critical values of this function, or the locations where cosine x is equal to cosine 2x, is going to be all of those locations at -2 pi over 3, 0, +2 pi over 3, +4 pi over 3, and +2 pi. So now I'm going to go back to my work here. And I am going to go ahead and I am going to write those values down. Those are my critical values. So my CVs, again, found from my graph, are going to be -2 pi over 3, 0 pi, +2 pi over 3, +4 pi over 3, and +2 pi. But again, my endpoints are -pi and +2 pi, right? So I don't really have to worry about testing beyond those. So now I'm going to go ahead and I'm going to create my number line for my sign testing. So my integral goes from -pi to +2 pi, right? And then my critical values here were at -2 pi over 3. Please ignore my spacing. These aren't evenly spaced, but that's how I'm graphing them. +2 pi over 3 and +4 pi over 3, right? But these are the end points of my interval there and there. So I really have 1, 2, 3, 4, 5 intervals that I have to test, right? And I need to come up with some test values that live in these intervals. So again, let's think about our unit circle, okay? And any point in there will do, and we can totally use our calculator to do the sign testing too. But keep in mind that when we're thinking about negative pi is right here. And -2 pi over 3 would be right here. So I need a value, or I need an angle that lives between -2 pi over 3 and -pi. It doesn't matter which one, just choose one that lives in the right place, right? So how about maybe like -5 pi over 6? That would work. So that's going to be my test point between -pi and -2 pi over 3. Then I need a test point between -2 pi over 3 and 0 pi, which is right here. So how about if I choose -pi over 2? Then I need a test point between 0 pi and +2 pi over 3, which is right here, right? So I need something that lives in between there. So how about if I choose +pi over 2? And then I need something between 2 pi over 3 and 4 pi over 3, which keep in mind 4 pi over 3 was the exact same location as my negative 2 pi over 3, right? So something in between those values would be pi. And then I need something between 4 pi over 3 and 2 pi. So how about 3 pi over 2? Okay, so now I've created some test values here. And remember that I am plugging these test values into my second derivative, right? And so the second derivative, the function that I'm plugging these values into, is going to be this one right here, right? Cosine 2x minus cosine x. And I just want to know, do these angles, negative 5 pi over 6, negative pi over 2, positive pi over 2 pi, and 3 pi over 2, do these make this equation positive or negative? I don't care what the value is, I just care about positive or negative. So I am going to use my graphing calculator again because this is the easiest way to do this. So I'm just going to go to my home screen. And if I'm looking at negative 5 pi over 6, right? And I plug that in for x in both cases, I'm going to have cosine of 2 times, because it's 2x, so 2 times negative 5 pi divided by 6. I need to close my parentheses, so there's my cosine 2x, minus cosine of negative 5 pi over 6 again. Like so. And I hit enter, and I get a positive value, okay? So that tells me that my first interval there is positive. And you're just going to continue this process. So the next thing that we're going to plug in is we're going to replace negative 5 pi over 6 with negative pi over 2, but we're doing the same work, okay? So when I plug that in, just for the sake of time here, my second interval between negative 2 pi over 3 and 0 comes out negative. Now, interestingly enough, my third interval between 0 pi and positive 2 pi over 3 also comes out negative. We do not have a sign change there. My interval from 2 pi over 3 to 4 pi over 3 is positive. And finally, my interval from 4 pi over 3 to 2 pi, where I'm testing 3 pi over 2, that comes out negative. Okay, so now I know that I am concave up from negative pi to negative 2 pi over 3. So let's write that down. I am concave up from negative pi to negative 2 pi over 3. And I am concave up from 2 pi over 3 to 4 pi over 3. I am concave down on the interval from negative 2 pi over 3 to positive 2 pi over 3, because it doesn't change sign, remember, at 0 pi. And I am concave down from 4 pi over 3 to 2 pi. Okay. And then the other piece of information is anytime there is a sign change, you're switching from concave up to concave down or concave down to concave up, I know that those locations are going to be inflection points on my graph. So I know that I'm going to have an inflection point at negative 2 pi over 3, an inflection point at positive 2 pi over 3, and an inflection point at 4 pi over 3. So my inflection points, to calculate them, f of negative 2 pi over 3, f of positive 2 pi over 3, and f of positive 4 pi over 3. Sorry, I'm running out of room. Those are going to be my 3 inflection points of my curve. And again, I am plugging those into f of x, not into f prime or f prime prime, because it's the point on the original function. So when I plug those in, f of negative 2 pi over 3, again, I'm plugging that into 2 times cosine of the x value plus sine of the x value quantity squared. So let's just go through the first one of those together in the next video.